Hi guys, it's Mrs. Anderson. I am back with our new lessons for the week as promised. I was hoping these videos will be better, so let's give it a try. So we're going to do 7.3, and if you remember from last week, we were solving one-step equations using addition and subtraction. And these are the notes from last week. How when we saw an addition symbol, we needed to use subtraction, and when we saw a subtraction, we needed to use addition. Where this lesson is going to focus on the multiplication and division. We're going to be following these same steps in our solving one-step equations. So let's just get to it. So on page 310, I'm going to go over the key ideas. When you multiply each side of an equation by the same non-zero number, the two sides remain equal. So you can see here, as long as we do times 4 on one side and we do it on the other side, the equation is still balanced. Remember the old saying, whatever I do to one side, I must do to the other side. Just like when we were dealing with fractions. Whatever I do to the top, I must do to the bottom. So here, looking at an algebraic equation, x over 4 equals 2. Our variable is the x, and that's what I want to solve for. I want to know, what is x worth? So just like last week, I want to isolate the variable. That's my goal. So I want to get rid of this divide by 4, because remember, fractions are division problems. So if you remember our notes, the opposite of division is multiplication. That's the inverse operation. So to get rid of this divide by 4, I need to multiply by 4. And whatever I do to the one side of the equation, I must do to the other. This 4 will cancel out with this one. I am left with an x all by itself. And then 2 times 4 equals 8. And that's my solution for x. If I were to check that, I could plug an 8 in here and then ask yourself, what is 8 divided by 4? Is that 2? Yes, so you know you did it correctly. So here's another example in section 1, and I believe the online book will have like these little red arrows here that you can click on and watch small little videos right in that online book. So this looks very similar to the problem up top. We want to get rid of this divide by 4. Again, I'm going to isolate the variable. So if I multiply this side by 4, I need to multiply the other side by 4. 12 times 4 is 48. Then we have that fraction. That was a little, could have been a little bit confusion last week, a little confusing. So I want to get rid of this 2/7. And remember, when we have a fraction, all you're going to do is multiply by the reciprocal. Flip that fraction over. So if I flip 2/7 over, it's going to be 7 over 2. Now I can cross cancel everything on this side, and I'm left with x all by itself. Since I multiplied this side by 7/2, I need to multiply this side of the equation, this side of the equal sign, by 7/2. I can cross cancel 2 and 6. 2 can go into 2 once. 2 can go into 6 3 times. 7 times 3 is 21. And that's how they got that. So we're going to do some of these on your own. And I'm going to do them right here in my notebook. So I'm just going to write up top my multiplication and division. These are the inverse operations. Those two will undo each other. So number 1, a over 8 equals 6. And just like last week, we're going to make our fence. We don't see our book doing the fences, but that's what we're going to do. So step 1, copy the problem. Feel free to write these notes down in your ISN or notebook if you have one. Step 2, we're going to substitute the variable. No, we're not substituting, I'm sorry. Step 2, we're going to make our fence. under that equal sign. Step 3, circle the number on the variable side, because our goal is to isolate the variable. And when we isolate something, that just means get it all by itself. So I made my fence. I'm going to circle this fraction bar because I know that fraction bar means to divide. So I'm going to do the opposite and multiply. So I'm going to multiply this side by 8, and whatever I do to one side, I must do to the other. So that is actually step 4. Do the opposite operation on both sides. So a divide by 8 and a times 8, that's going to cancel each other out. I'm going to get my variable all by itself. 6 times 8 is 48. And then step 5, which is just a nice step that I always like to do, is to check, just to make sure your answer is correct. If I were to plug in a 48 up here, this would now say 48 divided by 8. And I want to know, is that going to be equal to 6? Well, 48 divided by 8, yes, that is 6. 6 is equal to 6, so yes, I know that is a correct answer. I'm going to do another one. This one has a fraction. 14 equals 2y over 5. And you kind of had a preview of this last week. I thought we did a couple fractions last week. So I'm going to make my fence under my equal sign. I want to get rid of this 2 and the 5, both of them, because that's going to isolate my variable. When I have a fraction, I'm going to multiply by the reciprocal. And whatever I do to one side, I'm going to do to the other side. I can always put this over 1, and then this will all cross cancel, and I'm left with y by itself. Now over here, I can cross cancel. 2 can go into 2 once, 2 can go into 14 7 times. 5 times 7 is 35. 35 over 1 would just be 35. Now if I plug that back in here, this is just going to be my checking over here. So if I had my 14 equals 2 over 5 times 35, because that's what that means when a number is directly next to a variable. That means to multiply. Now on this side, I can cross cancel. 5 can go into 5 once, 5 into 35 7 times. 2 times 7 is 14. And now I know that is the correct answer as long as these two are equal. So this is a two-step equation and we don't do those. So I'm just going to skip that one for right now. So let's go over here for division. When I see division, I'm going to use multiplication to undo it. So right now I have a number directly next to a variable. That means to multiply. The opposite is to divide. So that's where you see this divide by 5, divide by 5. I could add a fence here. They just don't do it. You got a real life situation you can look over on your own. And I'm just going to jump right to a couple more examples for you. Yep, and here we go. Everybody remember our blinking? Still haven't solved that issue even on a totally different computer. So hopefully that will die down in a minute. So I'm just going to copy number 4 down on my notebook. P.3, that means multiply. Remember, we do not use an x anymore because that could be a variable. So P times 3 equals 18. P dot 3 equals 18. I'm going to follow these same steps that we listed earlier. Maybe put a light on. There you go. Okay, so my fence goes under my equal sign. Circle the number on the variable side. I'm going to include that little dot there because I know that means multiply. But when I see a multiplication, I need to use the opposite and divide. So I can divide by 3 and divide by 3. Do it to both sides. 3 divided by 3, that cancels out. You're left with just P. 18 divided by 3 is 6. Now I can check that. I'm going to plug in a 6 for my P. So 6 times 3 equals 18. Is 6 times 3 18? Yes, it is. I know that is a correct answer. And let me do just one more. That's all I have room for. 12Q equals 60. Make my fence. Circle the number on the variable side. This time I don't see a dot, I don't see an X, I don't see parentheses, but I know when a number is directly next to a variable that's to multiply. So the opposite is to divide. So 12 divided by 12 is 1. 1Q is just Q. That's what I want, my variable by itself. Whatever I do to one side, I must do to the other side. 60 divided by 12 is 5. Now I can come over here and just check just to make sure I got it right. That way when you're doing this, before you even hit that little check button on the online questions for the bigideas.com lesson, you can see if your answer is correct before you even have to check it. You should know. So instead of a Q, I'm going to use a 5. So I'm going to rewrite this. 12 times 5 equals 60. And is 12 times 5 60? Yes, it is. I know I got that one correct too. And that's it, guys. So hopefully you can now go to bigideas.com, and I have an assignment waiting for you there. Have a great day.